registers, we know that data flows in and out of the CPU, that is central processing unit. The data may come from the analog to digital converter, which might have been obtained from the transducer or sensor device or from some other locations. Similarly, data may go out from the CPU to the digital to analog converter or to some other locations within the microprocessor based systems. This is called data transaction. Okay? The CPU requires some temporary storage cells so that intermediate data can be stored temporarily, either for data transaction or for later use. These temporary storage cells are called temporary registers. Registers are nothing but temporary storage locations. Okay? The register may be 8-bit or 16-bit or more, depending upon the processor. Common types of registers are accumulator register, data register, status register or flag register, program counter PC or instruction pointer IP, memory address register, that is MAR, instruction register IR, general purpose register, that is GPRS, and stack pointer register SP. There are many registers are there. These all are common type of registers. Okay. First one, accumulator ACC. It is a register 8-bit, 16-bit or 32-bit that primarily stores the result of mathematical, logical or other operations. ALU does the operation and accumulator stores the result. Okay. Next, data register. Data register is a special register which holds data when they are fetched from the memory or input devices. So it holds data. Okay. Next, flags. The flag register in the microprocessor is a special purpose register in which the individual bit values represents the standing of a result byte. The flag bits are automatically modified in accordance with the result and the type of operation performed. For example, consider the result byte could be a positive or negative after mathematical operation is over, and a dedicated flag bit implies this piece of information, that is whether the result is positive or negative. Okay. In another situation, the result byte could be a result of some mathematical or logical operation and resulted as 0. A corresponding flag bit indicates this information, that is whether the result is 0 or not. Okay. Following flag bits are common in microprocessors and microcontrollers. That is first one, carry bit. If there is a carry during operation, then the carry bit is set to high. Otherwise, it is 0. Okay. Parity bit. The microprocessor checks the even or odd number of 1 in the result. If the number of ones in the result is even, then the parity bit of the flag is set to 1. Next, 0 bit. Following the execution of the operation, if the result is 0, then the 0 bit of the flag is set to 1. Sign bit. The microprocessor checks the most significant bit of the result. If the result is negative, then the sign bit is set to 1. Means that indicates the result is negative. See here in this figure. So This one is a flag register. This one is carry bit, parity bit, Z that is 0 bit, S represent sign bit, and X, this bit is not in use. Okay. So for example, consider after some arithmetic operation, the accumulator content is this one, that is 0 0 0 0 0 0. Okay. See here the corresponding flag bit. Here the result is 0, right? The result is 0. That means this 0 bit must be high, right? See here, this is carry bit, this is parity, this is 0, and this one is sign bit, right? See here, this 0 bit is high. That indicates the result is 0, right? And sign bit is 0. That means the result is not negative number. Okay. Okay, in the next video, I'm going to continue that remaining registers.